Hello Warriors, this is Miss Lemons, and today we're going to continue our practice calculations with the mole. But this calculation is going to be a two-step problem. So before we get started, make sure that you have your mole concept packet out, and we're at question 25. If you're willing to look at the other or simpler calculations earlier on, I've made 4 other videos that go over the steps of solving those. So be sure to check those out before you do this problem. You're going to need that packet, a pencil, a calculator, and your periodic table. So this question is asking us, how many grams are there in 4.3 times 10 to the 25th atoms of mercury? So let's do the SUX method. We are starting with 4.3 times 10 to the 25th atoms. Okay, and then they are looking for how many grams. Now we need to figure out which conversion factor we are going to use, and so we are going from atoms to grams. We need to find a conversion factor that contains both atoms and grams. So let's look at our 2 conversion factors up here. Is there a conversion factor that includes both atoms and grams? And the answer is no. This one has moles and grams, and this one has moles and particles. Remember, particles can also be atoms, so moles and atoms. But not one of them contains both atoms and grams. So that means we need to combine them in a daisy chain, aka we need to do 2 steps. So we know that we're going to be using this first one, Avogadro's number. We are going to be using the second one, but to set this one up is a lot easier. Why? Well, we're already given all of the numbers, 1 and 6.02 times 10 to the 23rd. The only thing that we need to change out is this x. The x needs to be changed out for mercury symbol, Hg. Now for the other one, the molar mass, we have 1 mole of X, which we're going to replace with Hg, is equal to a number of grams of X, or Hg. That number comes from the periodic table. So let's take a look at our P tables. All right, so lead is element number 80. That means it has 80 protons. And we want to look at the average atomic mass, or what we've learned, the molar mass, because this tells us how many grams of mercury are in 1 mole. So if you were given a mole of mercury, it would have a mass of 200.59 grams. Likewise, if you were given a mole of sodium, it would have 22.9 grams. Okay, so we are using mercury, and its molar mass is 200.59 grams per mole. So we are going to use that value and plug it into our conversion factor. Now that I have all of the tools that I need, I'm going to go ahead and start setting up my formula. Every single calculation is going to start the same way. We're going to start with what we know over 1. So that is 4.3 times 10 to the 25th atoms of Hg. And yes, you do need to have both the unit as well as the symbol. You need both of those there. That will always start over 1. And I know that I'm going to be multiplying it by some sort of conversion factor. So we need to figure out what numbers are going into this conversion factor. Well, what's on top must come down. So if I have atoms of Hg on top, I need to have atoms of Hg on the bottom. So I'm going to go ahead and write that down. Okay, well, how many atoms? Well, this fraction is actually going to be our conversion factor. So we have to look at the conversion factors that we picked. We We've got 1 mole of Hg is equal to 6.02 times 10 to the 23rd atoms of Hg, or 1 mole of Hg is equal to 200.59 grams of Hg. We need atoms. The only conversion factor that has atoms is Avogadro's number. And the number that's tied to atoms is 6.02 times 10 to the 23rd. So that's what I'm going to be putting on the bottom. Okay. So now that we've got that, we've used 1/2 of our conversion factor. We need to use the other half on top. And if I were to stop here, I know that I'm canceling atoms on top and atoms on the bottom, but I would be left with moles of mercury, and we don't want that. We want grams of mercury. So we're not quite there yet, which means we need to do another step. Okay, so what's on top must come down. If we have moles of mercury on top, we know we want moles of mercury on the bottom. So I'm going to write moles of mercury. How many moles? Well, we already used up the mole over here. We used up this whole conversion factor, so we can't use this anymore. But we still have this one open, and we only have one side that says moles, so we know it's going to be 1 mole. What goes on top? Well, we've already used this half, so we have to use the other half. So 200.59 grams of mercury goes on top. Now, if you pay attention closely, you'll see that atoms on top cancels with atoms on the bottom. Moles on top cancels with moles on the bottom, which leaves us with grams of Hg, which is what we are trying to find. So because I know I've successfully canceled out all of my units, I'm going to go ahead and multiply my numerators together and my denominators together to get a new value. When I multiply 4.3 times 10 to the 25th times 1 times 200.59, I get 8.62537 times 10 to the 27th. 1 times 6.02 times 10 to the 23rd times 1 is 6.02 times 10 to the 23rd. We're not quite there yet because now we have to divide our top and bottom. And I'm going to swing it over here. So I'm going to start back over here like a little arrow. So when I divide the top and bottom, I end up getting 14,327.857. That's the raw, unrounded number. But of course, we need to round according to the rules of sig fig. So how many sig figs are in the coefficient of our starting value? This one right here. We would have 2 sig figs. Oops. And that's because both of these values, the 4 and the 3, are non-zero digits, and non-zero digits are significant. So we're going to underline our top 2 place values, and we're going to round. And because this is less than 5, we're going to go ahead and round down. So your final answer is going to be 14,000 grams of mercury.